The shape analysis is the process being used to determine the particle sizes of gravel and fine aggregates. A sample of the material is thoroughly dried and shaken through a series of sieves ranging from coarse to fine. The amount on each sieve is weighed and recorded. The AASHTO AAS-HTO standard sieve sizes for soil aggregates are presented as following. As you can see here, there is sieve number in inches and by number opening in millimeter. Material finer than number 200 sieve 0.075 millimeter is not visible in determining the particle sizes. Instead, these are determined by observing the rate at which the grains settle through liquid or gas. So, under the Stokes law, the rate of settlement of solid through a given liquid or gas is proportional to the square of the diameter of the solid. Test. So, number 1. Sample of the material passing number 10. Sieve is mixed thoroughly with water and dispersing agent that dissipate any electrolytic bonds in the sample that might cause flocculation and acceleration settlement. Number 2. After 12 hours, the mixture is agitated, making oil particles suspended in water. Is number 3. The mixture is then placed in a graduating flask, allowing the solid to settle under the pull of gravity. So the next is number 4. The bigger particles settle first, followed by the smaller, then the smallest one. The specific gravity of the liquid decreases. The changes are recorded by a special hydrometer and read at prescribed intervals. So, next is number 5. Change in specific gravity is related to the gain size of the material by Stokes' law. The last one is careful control of temperature and other possible variable is strictly observed to obtain satisfactory test results.
Good day everyone, I am Rodeline Aldaya and now we're gonna talk about the different kind of tests to evaluate the effect of moisture. The consistency of the soil varies from semi-solid to plastic, then to liquid if the water content is increased. Here we have 6 different types of tests: the liquid limit test, the plastic limit test, the plastic index test, the shrinkage test, the hand feel test, and the sand equivalent test. First, we have the liquid limit test. The AASH2 designation TET9 on liquid limit signifies the percentage of moisture at which the sample changes by decreasing the water from liquid to plastic states. When the sample is wet in the liquid limit, a grooved sample of soil in a cup will flow when lightly jarred 25 times. On the other hand, if the sample is jarred at the liquid limit, water separates the soil particles just wide enough to remove the soil mass shearing strength. Several tests in each sample are required to reach the moisture content wherein the groove in the sample is required to close at exactly 25 blows. This is the sample video. Second, we have plastic limit test. AH2 designation T90 signifies the percentage of moisture wherein the sample changes with lowering wetness from plastic to semi-solid condition. At this stage, the soil mortar starts to crumble when rolled into threads 1/8 inches diameter. Additional water will make the soil plastic, but sands are non-plastic material that its non-plastic limit cannot be determined. Third, we have plastic index text. AH2 designation T91 is defined as the numerical difference between its liquid limit and its plastic limit. It is also referred to as the percentage of dry weight. In some combination, it measures the fineness and shape of the soil particles, the interplay of the attractive forces tending to hold the clay mineral flakes together, the thickness and velocity of the water film, and the quantity and electrical charges of the cations. Here is a sample video of the plastic limit test and the plastic index test.
Okay, this is T90, the plastic limit of soils. So we remember when we were getting our sample prepped for the liquid limit soil, we were going to take a 10-gram sample of material once it has attained a plastic state and store it in a sealed container. From this 10-gram sample, we're going to pull off approximately a 2-gram subsample of this. We'll put the remainder back in a container and seal it. We're going to have a 2-gram subsample. It's going to be about the size of a pea. And we are going to roll it into an ellipsoidal shape, and then we're ready to begin. So we're going to place this onto a frosted glass surface, and what we are trying to accomplish here is we are simply going to roll this out with our hands, and we want to roll it at a rate of approximately 80 to 90 strokes per minute. And all we are trying to do is roll this out till it is 1/8 inch in diameter. And we have this reference tool here that is 1/8 inch in diameter, or the pin from your liquid limit device is also 1/8 inch in diameter. So we roll it out to 1/8 an inch. And once we have achieved 1/8 of an inch, which I have here, we simply reincorporate this back into an ellipsoidal shape, and we do it again. You want to be careful with how much pressure you put on this. What we're trying to do here is roll this out until we achieve a point where it begins to break and crumble before we reach that 1/8 inch in diameter. But we don't want to apply too much pressure and force it to break. We want it to do that naturally and on its own. So we've gotten to 1/8 of an inch again. We will reincorporate it into a ribbon or an ellipsoidal shape again. And we just continue this process again until we can't roll it anymore. It begins to break apart, and we can't roll it. And I'm almost there. So as we see now, it's beginning to fall apart. I can't roll it anymore. It's breaking to pieces, and we have not achieved 1/8 of an inch. So we will then take these crumbles and we'll put them into a tared container of known weight, and we seal it. And we then repeat this process, taking another 2-gram ball off of this 10-gram sample. And we repeat this process until the entire 10-gram sample is used up, and we have all of our soil crumbles into our tared container. We then weigh those crumbles. We get our wet weight. And then we dry this in accordance with T255, T265 to get our moisture content. And to calculate plastic limit, all it is the moisture content of this material rounded to a whole number. To get plasticity index, you would take your liquid limit, subtract your plastic limit from that, and get your plasticity index, and again, that will be a whole number. It includes T89, T90, liquid limit, and plastic limit.
Fourth, we have the shrinkage test. The shrinkage test measures the changes in volume and weight that occur as partly mixture of the soil and water, except sieve number 40. Sample is dried from the near liquid limit to constant weight of 110 Celsius. The results are stated in terms of shrinkage limit, volumetric change, and lineal shrinkage. Higher value of shrinkage factors show that the soil will give more trouble and problem. The volume of the certain soil increases when it absorbs water. Soils that are suitable for subgrade and base course are those that expand very little when moistened, and those that swell more are considered as poor materials. A common soil specimen requires more change limit of 1% for base coarse materials. This is the sample video.
Sometimes I'm all about the easy way. Sometimes I go for the gold. I never thought you were easy prey. I just knew I was sold. You probably knew all along what my intentions were. Well, correct me if I'm wrong, baby.
Fifth, we have the hand feel test. Experienced soil engineer deploy the hand feel test to approximately predict the plasticity index of the soil. The test may include tread toughness and moisture content approximating the plastic limit, the air-dried strength, dilatancy. Soil mortar processing high plastic index will produce tough treads and high strength without dilatancy. On the other hand, soil having low plastic index or PI will react in the opposite manner. Skilled soil technician could on a basis of this test predict the plastic index with standard error of about 1%. This is the sample video.
Maybe I was blind, known you forever while I tried to find someone that could be my great love. Right in front of me, I didn't realize you were my dream, so you took me by surprise. Oh yeah, even in my wildest dreams, I didn't think we were destined to be. And now you're laying next to me, everything feels like oh yeah. Wanna give you every part of me, I can't believe this is reality. And now you're laying next to me, everything feels like oh yeah.
6. Sand equivalent test. AASH2 designation T176 is for the field determination of the presence of the undesirable quantities of clay-like materials in the soil. Aggregate mixture is based on the volume rather than on weight. The sand equivalent is the ratio between the height and the sand column laboratory experiment test and the combined height of the sand and expanded saturated clay expressed in percentage. Higher values of sand equivalent indicated superior materials. The allowable moving average value from the California specification is 21 for sub-base, 31 for aggregate base, and 45 to 50 for aggregates of various types asphalt concrete, and 76 for concrete sand. This is the sample video.
I saw the city passing by my window. Was in the crowd, but I felt so alone. Looked at my phone like every other second. My future was blurry and numb, a tunnel where there's no light. Oh, but then you came and sat right next to me. Your eyes, they glowed and filled me up. We had never met before that time, but I just knew that we'd end up. You took it, you took it, took away my loneliness. So I know it, I know it. You're making me wholehearted. Together, together, together is always better. I don't want to be parted. You're making me wholehearted. You're making me wholehearted. We jumped off the subway leading nowhere. You rubbed off the cold around me. I heard you say that everything is alright, but how did you know how I felt? You saw right through me that day.
That's all. Next reporter, please.
So the topic I'm talking about is density test or soil. So the density of soil of a pre-cube foot varies with the peculiarities of the soil itself, the moisture content, and the compacting device plus the method of their use. So the main variable in the soil proper are the specific gravity of the soil, particle size distribution of the soil, grain shape of soil particles. So the specific gravity of the soil particles that may vary from 2.0 to 3.3, that is normally between 2.5 and 2.8. The next is particle size distribution of the soil. So, a mass compound of entirely pair of one size in the densest possible condition will contain 75% solid and 25% voids. The smaller the sphere in the mass, the higher the percentage of the soil solid. Hence, particle size distribution may greatly affect the density. The last one is grain shape of soil particles. Sharp angular particle will resist shifting from loose to a compacted state. Flaky particle in soil will decrease its density because they are difficult to compact.
About to report the laboratory test for soil density. So, there are classes of tests for soil density. First is the laboratory test to set standard for density. Second is the field test to measure the density of soil in place on the roadway. There are three types of laboratory tests according to basis of compaction procedure. Number one is a static test. It is determining the maximum density of soil sample in the laboratory. Number two is the dynamic or impact test. Samples of soil, each containing a designated percentage of water, are compacted in layers into mold of specific sizes. Number three, tamping foot or kneading compact test. The material is fed into a rotating mold and compacted by several repetitive loads applied through tamping shoes shaped like a sector of a circle. So here is the table wherein the details of dynamic compaction test. So field density test of soil in place. Field density test. It is the means of comparing the density with the laboratory results. The comparison is performed on the basis of relative compaction, defined as relative compaction is equal to the dry weight per cubic foot of soil in the roadway's structure, divided by the weight per cubic foot of soil sample at optimum moisture content compacted in the standard manner. Relative compaction is the only measure by which the acceptability of a completed roadway structure is measured. So field density and moisture content by sampling. Obtain samples of the compacted material being tested at full depth. Find the wet and dry weight of the sample. Then determine its moisture content. Determine the sample in the field by finding the weight of the materials required to fill the space. From the dry weight of the sample and the volume that it occupies in the field, find the dry weight per cubic foot. Find the relative compaction of the soil in field by dividing each dry weight per cubic foot by the laboratory standard density. So there are four factors that affect the accuracy of measuring the relative density. First is the change in the soil itself. Second, the sampling method. Third, the accuracy of laboratory testing for standard density. And lastly, the accuracy of testing field density. So let's have the strength test. So strength test or test for load carrying capacity, rate, and amount of consolidation in soils that supports the foundation. It is commonly applicable to bridge foundation. Test to measure the supporting power of distributed soils as compacted under standard procedures. So the first strength test is the California Bearing Ratio method or the CBR method. This method combines a load deformation test performed in the laboratory with an empirical design chart to determine the thickness of pavement base and other layers. Steps in conducting the CBR method. First, the disturbed soil samples at different moisture content are compacted in three layers by static loading or impact hammer into the cylinder mold with 6 inches in diameter by 8 inches high. The specimen depth is about 5 inches. The 5.5 pounds hammer, a AASHTO standard density test, is used in the impact method. Next is the moisture density curve is plotted. The sample with greatest dry density is chosen. Third, the specimen in the mold is immersed in water for 4 days to allow saturation. Expansion of the specimen is recorded. Fourth, a small piston of 3 inches in diameter is forced into the confined specimen. Load deformation data is recorded. So here's how you compute the California Bearing Ratio or the CBR method. So CBR is equal to load of test specimen at 0.1 inches piston penetration divided by the load carried by the standard crushed rocks based on a 0.1 piston penetration. So here are the summarized steps in conducting the CBR method. Step 1. Compact by static pressure or by impact. Step 2. Graph and find maximum density. Step 3. Soak in water. And step 4. Apply load. So the next strength test is the HVEEM stabilometer method. This method measures the horizontal pressure developed in a short cylinder sample loaded vertically on its end. Stabilometer operating procedures. So 4 different samples are prepared on a short cylinder about 4 inches diameter by 2% inches high of different known moisture contents. Compaction is done using tamping foot or kneading compactor. Each compacted specimen inside the mold is compressed until water exudes from it and past several electric circuits wired in parallel through the base plate of the exudation measuring devices. So here is the stabilometer. So it was found out after several tests that soil is underlying pavements exceeded moisture under pressure of about 300 pound per square inch. It appears that soaking did not produce a condition of certain fine-grained materials. In effect, the exudation pressure is a different means in determining the moisture contents of the soil on the roadway. Moisture content in stabilometer test samples is set to bracket the 300 pound per square inch value on which design was based. So other tests or other strength tests will be reported by the next reporter.
Good afternoon, everyone. Good afternoon, sir. I'm Abadingo Ariel. In continuation of our reporting of assigned topic, so stabilometer test. After the expansion test is completed, the specimen is enclosed in a flexible sleeve and placed into the stabilometer. Vertical pressure is applied slowly at a speed of 0.05 inches per minute until it reaches 100 psi. The developing horizontal pressure is reduced to 5 psi. So using the displacement pump, then the turns of the displacement pump needed to bring the horizontal pressure to 100 psi. So our determine this displacement procedure is intended to measure the penetration of the flexible diagram and intersection of the sample. The resistance value R of the soil is computed by the formula. So R is a resistant value. So equals 100 minus 100 over PB. So PB meaning is vertical pressure 100 psi. So over pH. So pH is a horizontal pressure and PCI at PV of 160 psi. So minus 1 plus 1. So the resistance value of a fluid where pH equals PV will be 0. So the R value of an infinitely rigid solid pH equals 0 will equal to 100. Triaxial design method. This method is adopted by some agencies for comparison tests. So from the CS design. So the open system triaxial test, lateral pressure is held constant by releasing from the container as the increased load causes the sample to expand laterally. Have an procedure. Cylindrical semen is placed on the porous discs which are rested on traction cell. So second, specimen is enclosed inside the rubber membrane and sealed from top as well as bottom. So third, then the traction cell filled with water, thereby subjecting soil specimen and all-round cell pressure. So fourth is all-around cell pressure, which is also known as confining pressure, act uniformly all over the specimen. So the last is the now additional axial stress, also known as a deviator stress, is applied gradually until the sample fails. What triaxial test can measure? So axial strain can be measured by determining change in length of some sample by dial gauge or displacement transducer. So last is the pure water pressure can be measured by apparatus connected to pressure line after closing the valve in drainage line. Types of triaxial test of drainage condition and triaxial test. There are three conditions that can be visualized during triaxial test by controlling drainage through specimen. So first is the unconsolidated undrained test, referred as UU test. So second is a consolidated undrained test, referred as CO test. So the last is consolidated drain test, referred as CD test, nuclear device test. Recently, nuclear devices are determining in place densities and moisture contents are used. The principle of the measurement by the nuclear instrument is relatively simple. Gauge readings are easily converted to density and prevent moisture using calibration curves or microprocessors. The portable devices are of either the transmission or backscatter types. So I will give the next reporter to Mr. Devon. So thank you.
Okay, good day everyone. I'm the reporter. To those who know me, I'm Devon Kurt Laude, and to those know me, Operation Morning, Operation Afternoon rather. Okay, my topic is soil survey. Introduction. Soil survey describes the characteristic of the soil in a given area, classifies the soil according to the standard system of classification, plot and boundaries of the soils on a map, and makes prediction about the behavior of soils, the different uses of the soils, and how the response of management affects them are considered. The information collected in a soil survey help in the development of land use plans and evaluate and predict the effect of land use to the environment. Soil taxonomy. Soil taxonomy or the soil classification is a method of classifying soil into groups. This system is a hierarchical method of grouping soil by similar characteristics. 12 main groupings of soil into order exist. These order are broken down into smaller groups until a series is reached. The soil orders is andisols or volcanic, andisols desert, gelisols or frozen, histosols organic, vertisols shrink swell, inceptisols infant, entisols resistant, alphisols moderately weathered, altisols highly weathered, oxysols tropical, spud soils flatwoods, mollysols ferries. Soil series. Soil series is the lowest category in the soil taxonomic system. Over 2,000 soil series have been defined. They are generally named after a location near where they were first described. Control section, the part of the soil on which classification is based. The thickness varies among different kinds of soil, but mainly up is an 80 inches deep. Soil survey. Soil surveys are the primary reference available to help land management determine the potentials and limitation of the soil. Soil surveys are the compilation of maps and interpretive data published by USDA or the Natural Resources Conservation Service in RCS, published on a country or country group basis. Soil mapping. Soil mapping is performed by the soil scientist on the ground. These maps are generally conducted on the soil mapping unit level. Soil mapping units are generally soil series, soil complexes. Soil complex is a group of two or more soil series that are interconnected rather, that is not visible to the map then identify. As you can see, there's example for the soil mapping. There's a type of legend that can have the color. Soil survey use. Soil surveys guide planners and farmers to alternative for making land use decisions. Survey also predict crop yields for different soils and tell what crops, grasses, and trees are best. So to each soil, they also describe the soil and water management need to use each soil on a sustained basis. Soil association map. Soil association are the soil that are similar in many characteristics. The first map in the survey is the soil association map, good for getting a good idea of a soil or large scale. That's an example of a soil association map I attach in the presentation. Detailed soil maps produced on aerial photographs. Permanent feature are map, highways, ponds, river, etc. Soil mapping units are delineated and labeled with a code, number, or letters. I can find any example of this detailed soil map. Soil mapping precision. Soil are delineated with a line on the map. On the ground, there is a railway, a sharp developed between soils. The change from one soil to another way to very gradual. Soil series description are also, for a tropical example, variation between location occur as well. Soil series descriptions. Generally, characteristics are described in this section. Parameters such as slope, drainage, fertility, and landscape position are described. A detailed soil profile described is also included in this section. Soil tables. Several tables are included in the soil survey. They contain information on the soil in relation to several parameters, engineering properties, buildings, roads, ponds, septic system, landfills, and etc. One land usage is one of the. Then wildlife habitat and crop stability. The history of soil surveys. Soil surveys have been produced since the early 1990s. Surveys are various states of becoming outdated. NRC has the balance to the effort to map new areas with updating previous map areas. The future of soil surveys. New technology is pushing the soil surveys program in a new direction. Computer copies of surveys are become available. GPS, GIS system is a mapping will be the standard, and the lead or improvement on the ability to use the survey on the ground versus farming. Refraction seismic. Refraction seismic is a surface geophysics method that utilizes the refraction of seismic waves in geology layers and rock soil units to characterize subsurface geology condition. This is the example of seismic refraction principle. The reflection and refraction when a scene A over scene B, V fitins 1 and 2. This, makita niyo dira dira example na graph. Application. First is oil. Applications is oil in the 1920s. Geotechnique, water prospecting, mineral research, landslide study, weathering zone determination for refraction seismic statics. Unfavorable geological setting with refraction seismic. Red ray paths are always hidden by shorter black rays. na naadira sa A and B na kuan. The record example of V1, V2, and V3. This is example of V1, V2, V3 record. And also the record example, refraction and reflection, air waves and surface wave. This is another example to make clear. Then the refraction data acquisition. For efficient processing, you need at least 2 offset shots, half spread distance, and second end shot, and 1 center shot. Nadiri sa graph na example, you need to be 2 offset shot. Ito offset shot is kanin narada kita ra dira by name na. Example of complex acquisition with 12 channels. This is the example. Equipments: geophones, seismograph, battery, cables, blasting box, radio, and portable drill. Energy source: sledgehammer, easy to use, cheap. Buffalo gun, more energy. Explosive, much more energy. Legal problems. Drop weight, need a flat area. Vibrator, uncommon use for refraction. Air gun for lake or marine prospection. Slender hammer, produce a good energy with high frequencies. Possible investigation deep in 10 to 15 meter. You can add stock fuse shot to improve signal noise ratio. To avoid aerial protection and improve energy, explosives can be burned into a small drill 1 to 1.5 meter using a portable mechanic drill or a jumper. Explosives: to buy and use explosives often difficult, impossible in some countries. A minor license is required. Processing: a few specific software are found to process seismic refraction. Most of them use conventional method like intercept time or IT, EBC, or GRM. New inversion software can be produced. Tomography interpretation. First, brick picking. This is the most important operation. Good picking in a good data. A common problem is the lack of energy for our offset geophones. Seismograph produce SIG2, SIGI, or special file format. Generally, they must be converted into another file format like seismic Unix. Picking FPV on a good data. This is an example of picking PV in a good data. And this is the poor data. Example of the picking FPV, the poor data. Travel time assembly. Still loop equals low velocity. Gentle loop equals high velocity. X-axis equals distance, and y-axis equals time slope equals 1 velocity. Bid-rock velocity. Using only offset shot, we can compute the true velocity of the bid-rock even if the bid-rock is dipping. If the points are not straight, it means that bid-rock is not homogeneous. This is a bid-rock velocity example. Anatomy. Move offset shot to end the shot and determine which part of corresponds to bid-rock arrive. Velocity determination. Velocity equals 1 over slope. Seismic velocity of some rocks. Sumpay ra ni siya guys. The rock repability. Repability of bulldozer is related with the rock velocities. A refraction profile can be used to determine if explosive use will be necessary instead bulldozer. Refraction survey can also be used to characterize soils, soft, hard to get excavation rates. If you know all velocity and intercept time, techniques can be computed below all shots except offset shot. What is an intercept time? This is the travel time, example of travel time. The intercept time formula. Z1 is a thickness layer 1, T1 is a intercept 1, V1 is a layer of 1 velocity, and V2 is a layer of 2 velocity. Plus minus method principle. Is a layer of 2 velocity. Plus minus method principle. C S in A equals V1 V2 times CDE time equals time ABCD plus DFG. Then the time is ABCDFG is the total time. This is a plus minus 1 total time example graph. Let's go now to the GRM principle. GRM principle is a general reciprocal method. See Palmer papers is valid for the ABC method. It takes an account of non-coincidence of the station used for calculating plus values. GRM requires more receivers than IT or ABC. Different distances are used to compute time to bedrock. GOP6 must select the optimal distance or the X and Y. General Reciprocal Method or GRM. This is a GRM example. The red is the plus method path and the blue is plus minus path. The blue color and red color. GRM 1 XY optimal distance selection. This is the example graph. And this is the depth with difference XY. The GRM 3. The GRM seismic profile sample. Now let's proceed to tomography. If you input all geological data and first break peaks, computer can build an theoretical model as close as possible to field data using difference algorithm. A very precise peaking and closer shots are required to give accurate results. Example 1 of geography on a gallery. And this is the example 1 graph. This is the profile 1, profile 2, 3, and 4. Then the example of landslides in sweep ups. Yung same gap po na to sa graph. This example sa profile 3, 2, and 4, 1. Thank you.